Sankalp, can you hear me? Sankalp, can you hear me? Is my voice audible to you? Sankalp, can you hear me?
Good evening, sir.
Very good evening. How are you?
Yes, sir, we're
Fine,
all
sir.
fine.
Okay, so Tharun has not yet joined. Why is he?
And Nitish as well, sir.
Exactly. Nitish has also not joined yet.
And one more thing, sir. Uh, like,
Yes.
uh, the assignment, I like submitted it to Bhaskar, sir. So, I couldn't submit it in the what is this? The learning room app. So I submitted to Bhaskar, sir. So you can correct it from him, sir.
Sure, sure. Okay, no problem.
Sir, am I
Today we
audible?
have a holiday.
Yeah, you are audible. Tharun, you're audible.
We had
Hey,
a rain
Tarun, you had a
holiday.
haircut, eh?
Yes. Nitish, where is Nitish? So let me know that is this screen visible to all of you?
Yes, sir, it is visible.
Exactly.
Good evening, sir.
So, yes, very good evening. How are you?
Yes, I'm fine.
Okay, so I think we shall now start, right?
Yes,
So we are discussing the water unit, right?
yes, sir.
Okay. So can you let me know that if okay, Thorn, can you tell me what is the chemical name of water? Sometimes it's asked.
Sir?
What is the chemical name of water? Water is H2O. What's its
H2O.
chemical? Now, what is the chemical name? How you will call it chemically?
Sir? Hey, turn
Yes.
on your video, sir. H2O, sir. Been 3 classes since you guys didn't turn on.
What will be the chemical name? Can anybody tell among you?
Uh,
Sir,
Shankar?
H2O.
is it hydrogen?
Yeah, what hydrogen? It is dihydrogen oxide, right? It is
Yes,
Okay,
sir.
chemical
okay,
name.
sir. Okay.
Yeah, exactly.
Chemical
It is.
name. Oh, okay.
I
Yeah.
can't see
Sorry, sir.
Sampa's video. It only says yes,
Displayed on
sir.
the wrong way.
Is it visible to all of you? Dihydrogen oxide.
Yes, sir.
Yes, sir. Yes, sir.
Exactly. Okay, then let's see the more properties of this water. So we all know that this water, it is colorless, right?
Yes, sir.
Yes, sir.
It is also tasteless, so it hasn't any taste.
It's
Sir, but it
Similarly,
feels good to drink it, sir.
yeah, it is very good to drink. Actually, it is having no color at all. So that is why actually it gets mixed with anything. We can add anything to it. I already told that it is your universal solvent.
Universal
So it is
solvent.
colorless, yeah, tasteless. It is completely transparent. Similarly, you can also remember that. So if I will just talk of conductivity, can you tell me is pure water good conductor of electricity or bad?
Yes, sir. It's
It's
good
a bad
conductor of
conductor, sir.
electricity. No, it's
Exactly.
It's a bad conductor, sir.
good. Oh, it's bad.
Pu-
Okay.
Pure water is bad conductor. That is impure water actually, which
Because
conducts
it
the
doesn't have any ions.
exactly because
No,
it doesn't have
yeah.
any ion, right? So pure water is bad conductor because doesn't has any ion in it. It doesn't have any ion because actually conductivity is because of ions or because of electrons. So since there is no any ion and similarly there is no any electron, it is just like this. We are having water molecule there, that is H2O molecule. And can you tell me what is the shape of this water molecule?
Sir, it's
Sir,
O,
two
O in
hydrogen
the
and
middle
one
and
oxygen.
like
O in the middle
O in the
and
top and
Yeah,
two
like
H's in the bottom,
connected to
sir.
it in the
The
side.
bottom.
yes,
Two
sir.
H, they are at the at what angle? Can
Yes, sir.
anybody?
Sir,
Triangle.
it's the
Degree angle.
some. Yes, sir. You told it last class, sir. It's octa
Yeah,
angle or something.
it is
Forgot.
104 degree. Yeah, 104 degree 5 dash
It's
5
called
minutes.
octa degree or what is it called, sir?
It is known as tetrahedral angle. Tetrahedral angle. I will write it here. It is known as
Sir,
actually
I don't remember you saying this, but I know it's
okay. That is
Why
great
did you
then.
tell
But
it, Raj?
Sir said this.
I don't remember
don't
sir saying.
don't worry that if you
You don't
know it,
know.
that's good. If you not know, then you will remember it now onwards. That this actually here it is known as 100. Its angle is 104 degree 5 minutes, or you can also call it as 104.5 degree, or you can also read it as 104 degree 5 dash or 5 minutes. Now another very
Yes.
important thing here is that this water it is having which shape. So what will be the shape here?
104 degree and 5.
Triangle. It's
This is the angle. What will be the shape
What
of
is
this?
the word?
triangle.
What is the word
Triangle.
Triangular.
Yeah, this is a
It is
triangle.
no, it is shape is band shape, or we also call it as V shape.
Sir, so
Yes.
the
So
other
what
two
is the
heads they
word?
don't have a connection.
Excuse me, sir.
Yes, tell me.
So what is the word after conductor, sir? Is it because?
No, it is bad conductor because it doesn't have any ion in it. There is no any ion. Ion means either positively charged or negatively charged. There isn't any ion.
Yes, sir. That's what I asked. Is the word after conductor because?
Yeah, it's because only.
So have you got it that it is having V shape? Can you explain
Sir,
why
can you
it is
tell
V?
me what's the angle? Like the word for the angle again.
Angle is 104 degree 5 minutes.
The name for it. So you said tetra or something.
Actually, it is less than tetra. Okay, I will tell it. What is the tetrahedral angle? Okay, I will write it here. Tetrahedral angle. It is less than actually. Tetrahedral angle is 109 degree 5 minutes. So this is the tetrahedral angle, but it is less than tetrahedral. It is only 104 degree here. Tetrahedral angle. It is present in methane. Do you know methane? That is CH4.
Yes, sir. Yes, sir.
Exactly. In case of methane, the angle is tetrahedral angle. That is 109 degree 5 minutes. So you can compare with this that in case of methane, angle is 100. Yeah, CH4. That is 109 degree 5 minutes.
9.5
Exactly, 109.5. But in
or
case of
5.
water, it is less than 109 degree. It is only
Sir,
104.
can you teach us like the basics of these diagrams, sir? We've never learned this.
Yes, sir. We have never learned.
Okay, that's okay. Okay, that's very good that you told me. Okay, I will tell you in detail how this water is actually formed. So, can you first just look it here that it is just looking the capital letter V? Is it looking like the V capital letter?
Yes.
Yes, sir. It
Exactly.
is, sir.
Exactly. That is why it is known as V shape, or we also call it as band shape, right?
Yes, sir.
Yes, sir.
Okay.
So
Have you
45
written down?
degrees. It looks like
Yeah,
45 degrees, sir.
exactly. It is like the 45 degree. Okay. Now, have you written
That's
down
why.
this? Shall I move to the next page?
Yes.
One
Sir.
second, sir. I'm almost done.
I wrote
Okay.
it, sir.
So can you tell the spelling of tetrahedral, sir?
It's written that.
It is
I know,
T E
like,
T
is it?
R A H E
But
D
it's
R A
written.
L. Tetrahedral.
Okay, RAL.
Exactly. RAL. Okay, now let us see here that how this water is actually formed. See, we are having hydrogen. Can you tell me how many electrons are there in the hydrogen?
One.
One, sir. No. Electrons.
Oh,
Two.
Two electrons.
One. There's only one. There's only one. There's only one.
Exactly.
only
There is
one.
one electron in the hydrogen, right? Okay.
Helium has two.
Yes.
Hydrogen has one.
Hydrogen, its
Okay,
atomic
I
number is
thought.
1. So that's why
Sir,
it has only one.
I thought you asked how many hydrogen electrons are there.
Yeah, there's
There
only
is
one.
still one.
Yeah,
There's only
No,
one.
exactly.
like
In case of water,
hydrogen
there are
electrons.
Sankalp, you
exactly.
can't Sankalp, you can't defend it, right? You told it wrong.
No, I
Yeah.
thought sir told how many hydrogen electrons are there in
He
water.
said one thing. Okay, it's okay, sir.
Okay, it's okay. Still no problem. So if I'm just talking of the total number of electrons in the water molecule, then hydrogen electrons are 2 there. But in case of single hydrogen atom, there is only 1 electron. So we are having the 2 hydrogen atoms, so total 2. Now there is oxygen. Okay, I will write the oxygen in the center here. Now, can you tell me how many valence electrons are in the oxygen? Oxygen atomic number 8.
Sir, I have a doubt, sir.
Yes.
Okay, tell me.
Sir, why like in this methane, you said that the angle between one hydrogen and other hydrogen it is 1.9 degrees 5 minutes, right, sir? Sir,
100.
like why? Sorry, 109 degrees 5 minutes, right, sir? So why does it form methane only in 109 degrees 5 minutes, sir?
Mm-hmm. Not only in
Like
case of
why does it?
methane, there are various other examples in which it is 109 degree. For example, I will just give few more examples. For example, in case of
Sir, I'm
NH4.
saying.
Okay.
Yes, sir, I'm saying. Okay. Sir, I'm
Sir, so
saying
like
why.
if it's surrounded,
I will tell you that why in case of water angle is less than tetrahedral angle and
I think
why it is
that's wrong,
109 degree in case of methane. I will give you the
360
answer.
by 4 is not 109.
So it will be here also 109 degree 5 minutes.
Sir, that means if we
Sir,
add
I'm
all 4 angles,
Everything
it
will be
should come to
360,
360, right, sir? But it doesn't come to 360.
No, that is
Hey,
not here.
everything is not 109. 109. It's not 109. Everything is not 109. It's clear.
Yeah.
There. See the.
one time the
I will give you more examples and I will explain each and everything. You just keep listening, and then if there is any
No,
doubt, you
sir.
can.
My doubt was why
Mhm.
like only if it forms in 109 degrees point like in 5 minutes. Why
Yes, yes.
only
Tell
when
me.
it forms like that? Why does it become methane, sir? Like if it let's say that the angle is 110. It's not
Mhm.
methane, but if it's 109, it's methane. Why is it like that?
I will tell you the answer. It is very simple. First, let us see how water is formed. Then I will tell the answer of that also angle. Now, tell me, in case of water, we are having how many valence electron in the oxygen? There are 6, right?
yes, sir.
Exactly.
Sir,
So I will write these 6 electrons by these 6 dots like this: 1, 2, 3, 4, 5, and 6. Is it correct?
Sir, but there should be two electrons in the
yes.
first K shell, sir.
Yeah,
Oh,
I
that's
have
not a
written
shell.
here. I have written here the first
Yeah,
2
two.
electrons in the K, then the
Okay.
6 in the next. Okay, now tell me, and these 2 electrons, they will just form a bond. They will just share with each other. Mutual sharing will be there. Formation of covalent bond is there. So now this is how actually water looks. But now, because of these 2 electron pairs which are on the oxygen, there is actually repulsion. Okay, I will show it here like this, that there are 2 electron pairs here on the oxygen, and now it has formed the 2 bonds with the 2 hydrogen atoms. So its shape is like this. This is your band shape, and here the bond angle is which I already told, that is 104 degree 5 minutes, right? Now the
Yes,
question
sir.
is, yeah, now the question is very important here. That is like this. For example, if I just draw the shape of carbon dioxide, that is my CO2. So carbon is in the center and the 2 oxygen, they are at the corners. But here the angle is 180 degree. So now I will give you the reason that why actually angle changes. So here angle is 180 degree. That means, yeah, that is the linear shape, right? So carbon dioxide is having linear shape, right? But water is
Sure.
having bend shape. So why it is so? I will tell you the reason. Reason is that here in case of carbon dioxide, there is no any electron pair on the carbon. So these two electron pair, they are actually known as lone pairs, or they are known as unshared pairs. So that means they have not formed the bond. So they are known as lone pairs. They are lonely. They are lone. Lone pairs are what we call it as unshared pairs, right?
Yes, sir.
Yes, unshared pair. So unshared pair electrons, what they will do? They will just repel each other, isn't it?
Hello, sir.
Yes.
So, but carbon is like a metalloid, sir. It has perfectly
Hello.
4
Yes,
valence
tell me.
electrons.
If you are having any doubt, you can tell me. First, I will explain, then you can ask your doubt. See, in case of carbon, there is no any lone pair, there is no any electron pair, there is no any unshared pair on this middle carbon in case of carbon dioxide. So that's why its shape is linear. But in case of
Okay.
yes,
I get
in
it,
case
sir.
of
I get it, sir.
yes. So in case of water, there are two lone pairs, so they will repel each other. That's why bond angle will decrease. That means bond angle will not remain 180 degree here. So it will decrease and it will remain only 104 degree.
Sir, so like in a car like carbon dioxide
Yeah.
compound,
Mm-hmm.
the valence electrons in the carbon is
Yeah.
4,
Exactly.
and
It
there
is
are 2 oxygen. So totally in like in one oxygen atom, there are only 6 valence electrons in the outermost shell. So
exactly.
totally there will be 4 empty electrons. So these 4 electrons in the carbon, like
Mm-hmm.
they go and fit into the oxygens, like
Exactly. They
remaining
form
6.
the bond. Yeah.
Yeah, the 2 like
Right.
groups get
So like
separated. 2
so like
4
every
2
so like if every valence shell connects with the other compound, it is like it goes to 180. But if every electron in the valence shell does not connect with the electrons in the other valence shell, it repels.
Exactly. Due to the repulsion, bond angle will
Yes,
change. I will give you one more example on the next page. First, write down this. Have you written down this?
1 second, sir.
Okay, just write down it. I will give you more example on the next page.
Done.
Okay, wait. That is very important.
You should have written it when sir was teaching.
I was asking a doubt. When I was asking a doubt, you finished writing. Not my fault.
Because of
it kind of seems like your fault on this.
Even you didn't finish Nitish.
I already finished. I was just looking at the periodic. So you're gonna go to the next page, sir.
No, sir.
You just told me no.
So have you now completed?
Yes,
Sir,
sir,
one second, sir.
everyone's
Sir, I didn't
Sir.
finish, sir. I didn't finish.
everyone's finished.
stop saying.
I'll send them, sir. It's also videos, sir. So they'll send the videos, sir, so we can copy the
They'll
videos.
send study material which you can use.
Sir,
So you can continue, sir.
Okay, now see
Yes,
here
sir.
that if now I will just give another example that here I'm having H2S, hydrogen sulfide, right?
Yes, sir.
Yes, sir.
So here also you can see that sulfur, its atomic number is 16. So that means it has how many valence electrons? That is 2, 8, 6. So it has also 6 valence electron, right?
Yes, sir.
Yes, sir.
And hydrogen, it has only 1 electron, right? Okay.
Sir,
So that is
so H2S will also have a 104 degree 5, sir.
yes, that means less than exactly it will have angle. Okay, I will write it here that there are 2 electron pairs, that is lone pairs on the sulfur.
Okay.
So that means it will have same shape as that of water. So it's having bent shape or V shape. So it's also having bent or V shape, right?
Yes, sir.
Yes,
Exactly.
sir.
Easy.
104 degrees 5.
Only people like Tarun won't understand it.
Why? What did he do to you,
Wrong.
da?
Tarun
What
can
did he
also
do to you,
understand.
da?
It is an easy concept, so that you had to remember that
Yes, sir.
angle
That's so
Angle-
rude, Ra.
angle will not be
Yes,
the
sir, even-
tetrahedral angle. It will be less than that. Now, in case of water,
104
angle
degree.
was 104 degree 5 minutes, but here it will not be exact 104 degree. The angle will be less than 104. That is, it's let's say 103 degree.
How did you guys not feel that rudeness for me, duh?
Don't talk
We'll
about that.
continue with the class. Shh.
Sir,
You
five
will see-
times, sir.
Racism, duh.
5 minutes, sir.
Racism.
Yeah. People
Have you
don't
got
support
this
black
concept?
Sir, why is it different
Yes,
with
sir.
water and different with this, sir? That is 104,
Exact-
this is 103.
Okay, I will tell you the difference. See, actually, in case of water, we are having oxygen. Oxygen is having very small size. Sulfur is having bigger size, right? Now, what happens because of this? These two electron pairs, they will be just close to this oxygen, and when they are very close to the oxygen, there will be repulsion. When there is repulsion, bond angle will increase, so it will be 104 degree.
Oh,
5
there is
minutes.
no repulsion in the case of sulfur.
No, sulfur is having bigger size. There will be less repulsion. Sulfur is having bigger size. When we talk of
Bigger
size,
size,
oxygen.
lesser the repulsion.
Exactly. Bigger size, lesser will be the repulsion. And here it is the small size, so repulsion will be more.
Yes, sir.
Oxygen is having smaller size, hence more repulsion. And when there is more repulsion, that means bond angle will increase. Got it?
Yes, sir.
Yes, sir.
Okay, now tell me that we have already studied, so I hope you are remembering that effect of pressure on the boiling point. So can you tell me what is the effect of pressure on boiling point? I have already told that if pressure increases, what will happen?
Oh,
Pressure
Heat
increases,
increases, sir.
temperature to the boiling, and the
They are
temperature
directly
to the boiling point
proportional.
increases.
Exactly.
Okay, one
Pressure
at a
increase,
time, duh.
boiling point will also increase, right? And similarly, if pressure decreases, boiling point will also decrease.
Increase.
please, they are directly proportional.
Yeah, this is very
Yes,
important
how do I-
question because it is asked sometimes that if we increase the pressure, what will happen to the boiling point? And similarly, if we decrease the pressure, what will happen to the boiling point? So you had to remember that boiling point, it is directly proportional to the pressure.
Yes, sir.
Higher the
sir.
pressure, higher will be the boiling point. Got it? Now then let's talk that of density. This is very important concept. So can you tell me what is the density of water? What is density? It is actually mass per unit volume, right?
It's 1,000,
Yes, sir.
1,000, sir. 1,000 grams per
Meters cube, meter cube.
So I will write it here that
Volume.
1,000 kilogram per meter cube, sir. 1,000 kilogram per meter cube.
water has
Said.
density of
1,000 kilogram per meter cube.
it has density of 1 gram per centimeter.
1,100.
1
Same
gram
thing, sir.
per centimeter cube.
Exactly what I said.
Oh my god.
Stop fighting that uncle. What do you
It's my day to take revenge.
So density is 1
when
gram.
we start fighting?
It is 1
Yes, sir.
gram per centimeter cube. So you have to remember that it has very maximum density. But now there is very important phenomena that when we actually cool this water, what happens to its volume? What happens to its density? You have to.
Sir,
Hmm.
if we heat water from 0 degrees Celsius to 4 degrees Celsius, it will
Exactly.
shrink, sir. But after that, it will increase. So this
Exactly.
Anomalous expansion
phenomenon
of
is
water.
called as this thing, sir, anomalous expansion of water.
Exactly. So that we have to study actually. So have you written down this? Shall I move to the next page?
Yes, sir. Yes, sir.
And
Well, stop copying
Yes, sir.
everything I said.
You didn't say that at all.
I said anomalous expansion of
That
water.
Please
continues,
stop
everyone finished
speaking
writing.
rubbish. Concentrate in the class.
Anomalous
Expansion
behavior.
of water. Yeah,
Okay.
please, yeah.
Anomalous expansion of
Water.
So, for example, if I will tell you that I'm having ice, so ice exists at what temperature? 0 degree, right?
Yes, sir.
It smells also
or below.
Now tell me what will be the density of ice? Is it greater than water or less than water?
Lesser than water, sir.
lesser than
E-
water.
exa- Exactly, it is lesser than water. That is why it floats on the surface of water. So its density is 0.92 gram per centimeter cube. Right? So that means its density is less than that of water. So I will write it here that ice has lesser
Less dense.
density than water. So that is why it floats on the surface of water, right?
Yes,
Sir, sir, I have a doubt regarding the like the assignment sheet, sir. Sir, like you asked us a
easy.
question called like what is hard water? Like you didn't teach us
didn't
yet,
do
but
that,
like
though.
I know. No,
Mhm.
but like,
Hey, we don't care if you know that.
It's
You just
unpotable
So
water.
the question,
you
Soft
just
water is potable, hard water is not potable.
we will study in detail hard and soft water after this topic. I will just tell a few more properties here, then we will go through the hard and soft water, then I will tell in detail. You have not to worry about that. So ice has lesser
sir, like
density
here
than,
the question is the thing.
no problem, I will solve that.
Assignment sheet.
You just in today's class I will teach you the complete, that is the hot water and the soft water, what is temporary hardness, what is permanent hardness, how to soft the hot water, what are the various methods. I will teach everything, you just focus on. So ice has lesser density than water, hence it floats on the surface, right?
yes, sir.
Yes, sir.
Exactly, hence it floats. Now can you tell me that why ice is having low density than water? Can anybody tell
So
me?
because
Otherwise,
when
Mhm.
a liquid is cooled down, it contracts, even its density.
But ice is having maximum volume. Not ice is not having
Oh, it expand.
the-
Oh no, right, that's heating. Okay, sorry.
Mhm.
Yes, sir.
Actually there is one very important concept which we study in the higher class, but I hope you can
Sir, I
remember
didn't
that.
get one point, sir.
My point is,
Sir, like
my question is that why ice is solid? So solids have very high density as compared to the liquids, but here ice is my solid, but still it is having less density than water. So why it is so? It is actually
Sir, it's
because of the
because
fact.
when
Mhm. Okay, I will
sir,
tell you the
because
reason.
when
No problem. Ice has
because if water
cage.
gets cooled, its
Mhm.
mass will decrease, sir.
Mhm.
So I mean, not as it'll contract, sir. So
But
this
no,
will
ice
make the
expands.
density.
No, ice expands.
Congoil density is
Sir, expand.
ice
That's a
expands, sir.
Yeah.
Sir, it
So see,
contracts.
actually,
Ice
Sir,
expands.
okay,
what is
don't
ice
worry.
expand?
I will tell you in detail.
Wait,
So
let me
ice
explain.
has open cage-like structure. It has cage-like structure. Ice has cage-like structure.
Okay, so when ice
So like in the
expands,
chemical diagram,
Okay, I will show it diagrammatically. So this is my H2O water molecule, right?
Yes, sir.
yes.
yes, sir.
Now this oxygen, it actually forms a very special type of bond with another water molecule that is known as hydrogen bond. This dotted bond which I have shown here, it is known as hydrogen bond, H bond, hydrogen bond, right?
Yes,
Sir,
sir.
but how can it bond with another hydrogen when it's like valence shell is fully covered, sir?
Yeah, it is actually a very weak bond. It is not a it is only a very weak force of attraction. It is not any a chemical bond.
Sir,
See,
can you explain like what does this diagram denote? Like what is this diagram? We
it is
haven't like ever seen this.
no problem. It is the diagram of ice. Do you know ice? Ice is your solid form of
No,
water. So
sir.
that
Like this method of representation, sir. Like
okay,
this
no
method
problem.
of represent putting heads and then line. Like
Okay,
what is
okay.
this?
I will tell you in detail. You just first make it, then I will tell you. See, actually, I told that water has band shape, isn't it? I told that water has band shape. Is it clear?
Yes, sir.
Yes, sir.
Yeah. So that means if I write the water molecule like this, so it is having band shape, or I can also write it like this, which I have shown in this diagram, that is H, O, and H. So can I write water in the both forms? That means it is also band, it is also band, we can write, right? So now
Yes,
we are
sir.
having, yes, so now we are having various water molecules in ice. So this is one water molecule, then it is the second one, then it is the third one, then it is the fourth, fifth, etc. Now can you tell me here, what is this? This is the cage which is formed here. Is it a cage? Is it what we can say?
Yes,
It is
sir.
the space there, empty
Sir,
Yes,
space.
but
sir.
when bond is forming, it has to attract, right, sir? Then it has to contract, right? How does it expand?
I told that this hydrogen bond, it is a weak bond. It is not a strong bond. It will not contract. There is a left the space, empty space. This is the empty space. These boxes which you are seeing here, they are the empty spaces.
So
So
like
because
the density increases because the amount of mass contained is getting lowered.
now see here, when there is empty space, that means volume has increased, right? Volume has increased. When volume has increased, what will happen to
So,
the density?
sir, so the in
Yes,
the
sir,
like that box, like in between that area, it's just vacuum, sir.
Exactly. There is
No, it's not
empty
vacuum.
space. It is not completely vacuum. It is the empty space there.
Like
Air or oxygen or something.
the air has something in it right there.
Yeah,
That's
there
what
will
I'm
be.
saying. It's not vacuum.
It is not completely vacuum. There may be some air inside it, but it is their empty space. There is no any atom, there is no any molecule there, so it is the empty space. So because of these empty spaces, it has ice has very large volume. That means it expands. So when volume is high, that means the density will be low. So that is why ice is
Yes,
having
sir.
low density than water. Got it now?
Yes, sir.
This is very important concept. I hope you will draw this structure. You will also study it in the higher classes in the 11th class.
Yes, sir.
That's why it's very
Yes.
important. I hope you will understand it. It is very easy. That you have to remember that when actually ice is formed, when we cool down the water, when ice is formed, there is empty space left between the water molecules, which is known as cage or empty space. So that's why we say that ice has cage like structure. So because of this cage, it has very high volume, and when volume is high, that means density will be low. Got it?
Yes.
Yes.
Yes, sir.
Okay, now tell me that I am heating this ice. When I will heat it, what will happen? It will melt, it will form the water, right?
Yes,
Yes,
sir.
sir. So one
Let
second, sir. I'll just write it down.
okay, right.
Yes.
Just put it right there. So I can't see anyone's videos, so
Even I
But
can't see. I can only see Nitesh's video. I can't see Sankalp's video.
oh, you can. I
Yes,
can't see your
I
video
can
also,
see
Pongal. I
Nitish's
can't see
video.
the sun.
You
maybe it
can
is the
see
text.
Yeah,
everyone's
para.
video.
Everyone can see my face.
Now you can see, right?
Now I can see Pongal. Yes, sir, I can see Pongal.
You can't. You
Yeah,
still can't see me.
Yes.
No, it says SA.
Now.
No, I mean in sir's screen I can see. I can't see in my screen.
No, da. It just says this. Yeah, only in Sir's screen.
Yes, sir.
Sankalp is
Makes sense.
hacking.
I 0
So
So,
have you?
like in the first part of the reaction, it will
Mhm.
contract, and the second part of the reaction, it will increase, right, sir?
expand.
No.
Yeah.
In the first part, it will increase, density will increase, and then no, wait. In the first part, it will expand.
Mhm.
Second part will contract, and then in the third part, will again expand. That's the correct
Okay,
one.
I will tell you.
Exactly.
See,
So
when we are now heating this ice, so we have got that ice has very low density, isn't it? Ice has low density. Got it?
yes, sir.
Ice has low density. Okay, now tell me that if I'm heating this ice, so it will melt. It will form the water, right? Is it right?
Yes, sir.
Yes, sir.
Now tell me, when water is formed, what will happen to its volume? Will volume increase or decrease?
So volume
Sir,
will
Volume will decrease.
increase.
volume will increase.
No,
Decrease,
when density increases, volume will increase, sir.
See, when we
So
are forming
It's
this
inverse.
water,
sorry,
what will
sorry, sorry.
happen? these hydrogen
Yes,
bonds
sir,
will
understood.
break. Upon heating, some hydrogen bonds will break. So that means water molecules, they will come close. That means cage will now break. So that means volume will decrease. When volume decreases, what will happen to the density? Increase, right?
It'll increase, sir.
Yes, sir.
Exactly. Now again, I'm heating it up to 4 degrees Celsius. Now this is very important point here, which you have to note down, that at 4 degrees Celsius, volume again decreases. And when volume decreases, so that means density will also increase, right?
Yes, sir.
But after
Yes, sir.
4 degrees Celsius, if you again heat it, that means you are again heating the water. That means now it is the temperature 5 degree or more than 5 degree. What will happen now? Now volume will
Sir, it'll increase
increase. Now, can you tell me why volume will increase? Because now water, it will start
because of the
expand.
anomalous expansion of
It
the
will
water.
start evaporating.
Sir.
Because it will now
Evaporating.
expand. Yeah, it will now
Yeah.
actually
But
actually we
expanding or
know
evaporating. both.
actually we know that water, it has tendency to flow. It shows fluidity, right?
Yes, sir.
Due
What?
to
Yes,
fluidity,
sir.
Flowing da.
yeah, flowing tendency is known as fluidity. So that means water will now
Yes,
start
sir.
flowing. When it will start flowing, so that means what will happen? It will increase, volume will increase, because it will now flow. Water will flow now. There will be fluidity shown by this water. So when water
How does
flows,
the volume increase when it flows, sir?
when it flows, it will expand. It will just occupy maximum space.
So every
Isn't it?
time the waves are coming from the ocean, the volume increases in the ocean.
No, I mean to say
What?
that water. See,
Yeah.
tell me here that you are first having ice. So is let's say this is my ice, piece of ice, right?
Yes, sir.
So how much volume it has occupied? It has occupied this much volume. Now when I'm heating it, let's say the temperature is 25 degrees Celsius. I'm heating it to 25 degrees Celsius. So first it will
Yes,
melt it
sir.
to form water. But when water is formed, then water molecules will expand. They will now flow. Water has tendency to flow. So that means it will now occupy more volume. It will occupy more space. So that's why I'm saying volume will increase, so density will decrease. So after 4 degrees Celsius, volume again increases and density will decrease. So that is why it is asked most of the time is that water has maximum density at what temperature. So you will remember that it has maximum density at 4 degrees Celsius. Got it?
Yes, sir.
This is very important
sir.
point, so I will repeat it again, that first of all, if you are having ice and you are heating it, volume will decrease, but it will decrease only up to 4 degrees Celsius. After 4 degrees Celsius, what happens? Water will expand now unconditional. There is anomalous behavior, anomalous expansion. It is actually because of fluidity. Water will show fluidity. It will flow now. When water flows, so that means it will occupy more and more space. So that means volume is very high. When volume is very high, that means density will decrease. So that is why water is having maximum density at 4 degrees Celsius. Got it?
Yes, sir.
Sir.
Okay, now I will write it on the next page. So that at
Sir, can you go to the previous page?
okay,
What
just
are you doing all this while?
write down.
Yes, sir. I can change.
Have you written it down now?
Yes, sir.
Yes.
Only you can write this fast in school also.
Okay, now see here that I told that water has maximum density at 4 degrees Celsius, right? Water has
Yes.
maximum density at 4 degrees Celsius, correct?
Yes.
Yes.
Yeah,
Sir.
this is very important point and I hope you will remember it. Now, the next very important point was regarding the specific heat capacity. I think we have discussed that. Okay, let's move towards what is actually hot and soft water. Right?
Yes, sir.
Yes, sir.
Okay, so water can be soft, it can be also hot. So let's first discuss what is soft water. So can you tell me what is soft water?
Like what?
So it is usable.
Okay,
For
I will tell
daily
you. It is
uses.
the water which produces leather. Which produces leather.
Leather.
Sir, it produces bubbles when in contact with
Lather.
soap or something, sir.
Yes, that bubble soap that is known as leather. Yeah. So which produces leather with soap solution, right?
Hard water.
Yes.
It is the soft water, not the hot water, with soap
Yeah.
solution. So
Soft,
when
sorry.
yes, soft water is that water which will produce leather with soap solution readily. That means easily. That is known as soft water.
Lather. You mean like the
Yeah,
layers?
easily means readily. Readily means in very good quantity. So that means when there is formation of leather with the soap, that means when actually soap easily dissolves in the water, there is formation of froth, there is formation of leather. So we call it as soft water. Example of soft water is your rainwater. You will write the examples, they are very important. Rainwater. Similarly,
Before it
distilled
turns
water.
brown.
Do you know what is distilled water?
Yes, sir.
Yes, sir. The one we get from the
Yes, sir. So
water.
it's when all the
purifying water.
ions from the water are removed and it's just only pure water.
Exactly.
Purifying
So
It's
that means
just
that means you can also
H2O.
drinkable water.
demineralized water. Demineralized water is also your soft water. Means you have removed all the ions, all the minerals from the water, right?
So what is the
All the
first? What is the
impurities.
first example? What is the first example?
It is the rainwater.
Rainwater.
Yeah, rainwater.
Rainwater.
Rainwater is the best example of soft water.
Before it
So
touches anything, sir.
that means if you are using rainwater for washing clothes, it will be better because soap can easily dissolve in it and there will be formation of leather.
Can't
And
use it, sir. If it touches any surface, it will become not good for using.
exactly, when there is actually more pollution, then there will be acid rain. So due to various acidic oxides, rainwater is not preferred. But distilled water is then another example of soft water which you can use.
Sir, but we can't drink
So
distilled
then
water, right, sir?
we can
Yes,
drink
exactly.
distilled water. We can't drink any
We are
mineralized
drinking
water.
hot water because actually hot water gives the taste. It has minerals in it and which are very essential for our body. So that's why we are taking the hot water, not the soft water. Okay, I will give you the examples in detail. Let's see what is then the hot water. So can you tell me what is hot water?
Uh,
Sir, it's
doesn't
it's
lather
water that
with
is not
soap only.
potable. It's water that is not potable.
Water
What
which
that is
does not produce
Easily
leather,
lathered.
which does not produce leather, right?
Yes, sir.
Yes, sir.
That
Easily.
means your soap. That means your soap will not work in this hot water. That means there will be no production of leather. There will be no
Sir,
bubbles.
but
There,
then when
it
we
not.
bath, sir, but then when
Yes.
we bath, we use hot water, right, sir? But when you use soap, there's bubbles, right, sir?
Exactly. When we bath, the water is your soft water. That's why soap can easily mix with the water.
Soft water.
Yeah, that is
Yeah.
the
Do you
soft.
drink your bath water?
No, I don't.
Then what you're talking about? What do you
See,
mean
see.
hard water?
Yeah,
Is
and it lathers.
Environment conservation.
Yeah,
No,
that's what I'm saying.
that doesn't produce leather, so that is your hot water. Now you are confused
Sir,
in the water. See. I will tell you.
yes.
There are various sources of water. If you are taking water in your home that is actually containing various salts in it or minerals, then that's your hot water. Because hot water there are salts, there are minerals in it. That's why soap cannot work in it. But most of the water which we are using, soap can easily work there. So that's your soft water. That is not the hot water. So water
Sir,
which does
but like here in Chennai, there's a lot of sea water in the tap water, so it's very salty, sir. But then still it
exactly.
lathers with soap, sir. Oh.
Okay. See. I will tell you. That is not actually the complete soap. If we are using the detergent can work easily in the hot water. But soap cannot work in the hot water. Soap works only in the soft water. There is actually difference
Yes,
between
sir.
the soap and the
Oh,
detergent. I will tell it in
so
detail.
what we
Exactly.
use is detergent.
Exactly. We are using the
No.
detergent. The soaps which we are having
Oh my
nowadays,
god.
detergents.
Sir, I
My
use the
brain
same
is
thing I
lying.
wash my clothes with.
Yes.
So is it the same thing, sir?
If we start bathing with soft water, we have to bath with detergent.
I will just give you the example of this which is completely soap. That is the ring soap. Have you heard that?
Tap water. Oh, okay.
Yes, sir. The one they
Exactly.
use for washing vessels.
Exactly. So that soap is this
Cleans.
completely soap. So that doesn't work
That
in case of
doesn't
water.
lathers.
Exactly. So you will now
Yes, sir.
remember.
No
I hope.
bubbles.
Exactly. So
Doesn't
water which does
work if
not
I
fix
do
lather, that's for hot water. So can you give me the examples of hot water?
tap water.
Exactly. Your seawater, your
Sea
well water, tap
Sea
water,
water.
exactly. Tap water,
The water
seawater.
from an acid rain.
Exactly. That's also
I don't know if that's water there.
water from oceans. That's
Sir,
water from,
blue vitriol. Because it has copper sulfate in it.
yeah, whenever
It's
there
not
is any
even
salt.
water there.
It has water. Blue vitriol has water.
It is formed
But
like
below vitriol, that
Blue
is your
vitriol, sir.
below vitriol. See, that is just like this. That is your copper sulfate pen.
CuSO4 dot NH2OH, sir. 5H2O.
pentahydroxide.
It is your hydrated salt. What do you mean by hydrated salt? Hydrated salt is that which contains water molecules in it, water of crystallization. There are 5 water of crystallization. It is not
Water, but
water.
it's
It is
hydrated.
not water. It is a compound. It is not a water. So
Sir,
you cannot give this
what
example
about
in
dilute hydrochloric acid, sir?
dilute
Dilute hydrochloric acid. It has water
exactly.
to it,
If you
sir.
are
That's
having
not
water
water
and
either.
you are having few
Ah,
drops of
see, I'm right.
HCl in it, so that is your dilute. So it will also come in this hot
Dilute.
water.
Hot water.
Exactly, because hot water contains salts in it. There are salts, right? Salts of calcium and
Yes,
magnesium are there actually. So this is very important that there should be salts of calcium and magnesium, which makes it hot.
yes, sir.
Got it?
Yes, sir.
Now let us see what is the cause of hotness of water.
Sir. 1 second, sir. 1 second.
Okay. You just wrote it.
So who else got ready for school and got to know that there was no school? Was it just
I
me?
got to know that no, my dad knew that there was
Not
no school,
me.
but he made me dress up and
I was
do
about to
everything.
leave the.
I was in the car also, there.
My mom woke me up, but I still slept.
I woke up, took a bath, ate my breakfast.
Today morning
got
only you
ready,
said you
and
didn't even
then
wake up. Hey,
my mom said,
Uncle player.
no, I slept back again.
No, I
After this
said I
interview.
woke up. I sat in the car.
Shall I move to the
Yes,
next
sir,
page?
everyone finished. Yes, sir, we
Okay.
can go.
Yes, sir, you can, sir.
Okay, now let's see what is the cause of hotness. Why water is hot? So cause of hotness. So water is actually hot because of this two very important salts. That is actually the salt of calcium and salt of magnesium. So cause of hotness is presence of salts of calcium, and salts of magnesium, right?
Yes,
Yes,
sir.
sir.
So that means any water which has
Yes, sir.
calcium salt
We
in it
learned this.
or magnesium salt in it, so that is known as that means they are actually responsible for the hardness of water. So this is my reason that what is the cause. It is the salts of calcium and magnesium. Now it can be any salt, let's say calcium chloride, this salt. Similarly magnesium chloride.
Calcium sulfate, calcium
Exactly,
bicarbonate.
calcium sulfate can be there, magnesium sulfate can be there. So these are actually the salts which are responsible for the hardness of water. So similarly, calcium bicarbonate, right? Similarly, magnesium bicarbonate.
Yes.
Sir, but in water plus HCl there is no
MgSO32.
salt, sir.
Yes, in water
Water plus HCl.
there are the salts. In
Sure,
seawater, in tap water, similarly in the water from oceans, there are the salts of calcium and magnesium present. So that's
No,
why
sir, he's
those.
telling in dilute hydrochloric acid there is no calcium or magnesium salt.
That is why that is not the
Yes.
preferred example of hot water. That's why I didn't use the dilute
Simply
HCl
hard
as.
water.
But it's
Yeah,
still hard water only, right, sir?
actually, see, soaps doesn't work in hot water, and soaps also doesn't work in acidic water. So that is why we say that in acidic water soap doesn't work. But that doesn't mean that acidic water is your hot water. Hot water is
Sir,
only when
so
when. Mhm.
if I ask you that if dilute hydrochloric is hard or soft, what's the answer, sir?
Answer is no. Answer is no, because and there should be calcium and magnesium salt. It is only HCl. There isn't. If
So
see,
so it's
okay,
considered
okay,
as soft water.
I will tell you. I will tell you.
Consider
For
No
example,
water,
I mean,
yeah.
acid.
see. If
Yeah.
I am having water, you just focus on. I will just give the example. If I'm having water and there is also calcium ion there and there is magnesium ion, right? Let's say I'm having water. There is already calcium and magnesium ion. Now I'm adding HCl to it. Now what will happen? It will just form calcium chloride there, and there will be formation of magnesium chloride. Now it becomes hard water. So it is now hard water. Got it?
Yes, sir.
Yes. But if there is no calcium and magnesium in water and you are just adding HCl to it, then it will not be the, yeah, the hot water, right?
Yes, sir.
Yes. So this is very important. Now you have to remember these salts which makes water hard. So it is calcium chloride or magnesium chloride, calcium sulfate or magnesium sulfate. Similarly, calcium bicarbonate and magnesium bicarbonate. Now, what is the actual reason why these salts they make our water hot? So let's see the reaction. What actually happens here? So first of all,
Sir,
can you tell me?
I think it is because these salts, like, they occupy the space in between, like, those, that empty spaces, right, sir? I think it occupies that, so which makes the thing very rough. That's why it becomes hard water.
No. That is not the actual reason. So first, tell me what is actually soap. Can you define soap?
So it is soap is
Sodium or
C17H25COO
potassium, salts or higher
So random.
That is the soap. That is soap formula, da.
Oh
fatty
my God,
acid.
I didn't know that.
So this is the definition of soap. So what is soap? It is the sodium or potassium salt of higher fatty acids,
Fatty
right?
acid.
Higher fatty acids. You
Yes,
will
sir.
add higher fatty acids.
Sir, what is a fatty acid, sir?
Fatty acid
In
is
our
that.
stomach.
Okay, I will tell you. Fatty acid is your carboxylic acid, which contains large number of carbon atoms in it.
Okay.
Okay, I will write it here. Carboxylic acid, which
Sir,
contains
fatty acids are the one in our
Sir,
stomach, right,
what?
sir?
That is
fat,
hydrochloric acid.
That's
fatty
what I'm
acids are
saying. It's like lemon.
carboxylic acids which contains more number of carbon atoms. Got it?
Yes, sir.
Can you write the formula for
Sure, sure,
carbo,
sure. I will write the formula of
whatever
soap
that is?
as that of detergent. You have not to worry.
Yes, sir.
You first write it.
So you asked the question, right? So like something soap, sir. Long soap or no? Bone soap. The question, sir. Okay. Nothing, sir.
You first write it down. Then I will tell you the formula of the soap. Then I will also give you the examples of the soaps, different types of soaps.
So unfortunately, we can't hear you if you're speaking.
Have you written down? Shall I move to the next page?
Yes, sir. You
Yes,
can
we
move to
can
the
hear
next
you.
page, sir.
We can hear you, Kongoil.
We
Oh,
can't,
okay,
Ra.
okay. Now,
Oh, now we can.
can you hear me now? Oh, okay.
Yeah, now okay.
Shall I move to the next page?
So one
Yes,
second,
sir.
I mean last slide. Bruh,
Hey, Pongwell left and still he finished, Ra.
Write down
This
fast.
is like started
Pongwell
when
is
sir is teaching
omnipotent.
itself.
So I will write the general formula of this soap.
yes, sir, done, sir.
Okay. So now see here that in case of soap, and the formula, the general formula is written like this. That is my R, C, O, O, and Na. or you can also represent the soap by R, C, O, O, and K.
Sir, what is R?
Okay, I will tell in detail. What is this? It is my sodium, right?
Yes,
Sodium,
sir.
Oxygen.
Okay, what is this
Carbon.
K? K is the potassium.
Potassium.
Sir,
potassium.
So I told that soaps are the sodium or potassium salts of higher fatty acid. Now acid contains this group, that is COO. Here it's also COO, right?
Yes,
No,
yes.
you
Sir.
can write CO as CO2, right, sir?
Bruh.
Yes, you can write
not-
it as CO2, but it is
Sir, but
preferred
how-
as CO.
So how can you write it? So it's not chemical, like it combines.
It is combined. We can write. Okay, I will tell in detail. It is just like this. R has formed the bond with the carbon. Then there is double bond with one oxygen. Then there is the single bond with another oxygen. Then it is the Na. It is like this.
Oh, okay. So like
Yeah.
oxygen and oxygen don't bond.
Exactly. It is the oxygen has formed a double bond with the carbon.
Oh,
Yes, exactly.
They are enemies.
Now,
Soap curd. Yeah.
now I will give you the example of soaps. Now, one of the best example
but
of
I
soap.
don't get it, sir. Why does oxygen
No.
bond with N?
Okay, sir.
Like, why does oxygen bond with Na, sir? Like, the two oxygens can directly bond with the carbon and create carbon dioxide, right, sir?
It is like this. It is oxygen. There is negative charge on the oxygen and positive
It's
charge on the
made
sodium.
that way.
So it is made actually. It is synthesized. Now see
Sir,
here.
like, can you even do it like just CO2 and Na?
R. What about the R?
No. You
Okay,
cannot.
can't do it.
You can just have this one. That is the sodium carbonate, Na2CO3. This is the compound. It actually exists. Okay, now so I'm just giving the example of soap. That is my sodium stearate. Sodium stearate.
It's alkali sulfonic acid.
That is actually the detergent. I will first tell the soap. So sodium stearate, it is formula is like this. That is C17, H35,
I was
and
like
then it is my
COONA.
COO and Na. Now here you can easily see this is my sodium, this is my COO, and this C17H35, this is my R.
Sir, what is R? So it
Oh, I
can be
was right.
replaced with anything.
Yes, we can replace it with any long chain. So that's why I told it is the higher fatty acid.
R is
Higher
more
means
preferred.
it should have carbon
Oh,
number
so
greater
R
than
stands
12.
for fatty acid.
Exactly. It should be carbon number should be greater than 12.
Okay, R is the fatty acid.
So another
So
example of
R is
Yes, I
basically
don't.
the fatty acid, right?
actually this R is
Yeah.
known as alkyl group. In organic chemistry, we call it as alkyl group. So I hope you will remember it. Alkyl group.
Okay, sir.
So
Sir,
fatty
I'm
acids
saying
are
we
also called as alkyl
Fatty
group.
acid, it is a whole as a fatty acid. It is my sodium stearate. So this is the whole fatty acid. Stearic acid, that is my fatty acid. So now you have to remember that this carbon and hydrogen part, that is C17H35, this is your alkyl OR group, right? Got it?
Yes.
yes.
Yes. So another example of soap I am giving here, that is the sodium palmitate.
Sir, this alkyl group, is it like the group 15, group 17? Is it like that or?
No. It is not like that. It is your just alkyl. It contains carbon and hydrogen.
Okay.
Okay. Now sodium palmitate. What is the formula of sodium palmitate?
We
Is
don't know,
C.
sir.
No, sir.
It is
Sir,
C17H31.
it is C17, H30. Okay, okay.
Exactly. H31, then CONA, right? So it's another example of soap.
Yes, sir.
Similarly, another example of soap is sodium olate. Sodium,
Olate.
yeah, olate.
C17, H38.
That is
Eight. Oh my God.
Nice name.
that is C17H33.
Ah, that was so close.
L.
So these are the three examples of soaps. I hope you have got what is actually the soap. It is the sodium or potassium salt of higher fatty acid, right?
Yes, sir.
Sir,
Okay, now let us see the reason that why actually. Have you written down this?
Yeah,
yes,
yes,
sir.
sir.
Yes,
Yes, sir.
sir.
Sir, you're still
So what
missing.
about alkali sulfonic acid? The one I
Stop
saw.
it
Sulfonic
with
acid,
it,
that is detergent. That is not the soap. I have just only told you what is soap, not the detergent. That is your detergent. What you are talking of, that is the detergent.
Yes.
Okay. Okay. Now
Googling it continuously. Then.
let us see that why actually soap, it doesn't work in case of hot water. So now tell me that when you are having hot water, so what will be there? There will be calcium ion, right? That is Ca2 positive, right?
Yes, sir.
So it will react with the soap. So what is your soap? Soap is your, let's say, sodium stearate. I am taking C17H35.
17 H35 R
Yes,
RCONA.
exactly. Okay, okay. You can also write it as RCONA or just like this. Now tell me what will be the product here. Product will be like this. That is C17H35.
Sir,
Then
it
it,
can't happen, sir.
Why can't it
I will tell
happen,
you.
Raju?
I will tell you what will be the product.
Like Na and Ca are like both positive.
This reaction will take place. It is calcium stearate will form here. That's my PPT here, precipitate. That is why it doesn't
What?
allow. It is my precipitate. Do you know what is precipitate?
Yes, sir.
Yes, sir.
That is the solid product which is insoluble in solution, right?
Insoluble salt. Yes, sir.
Exactly, insoluble salt. And you will here also get the sodium
Sodium.
ion. So due to this precipitate formation, it doesn't allow soap to form the froth. So that's why soap doesn't work in hot water. So this was my hot water, right? Because hot water actually contains the calcium.
Uh,
So they,
excuse me, sir.
yes, tell me.
Sir, the other class started, sir.
Okay, sure. Now we can stop today's class. But have you got this now? Why soap actually doesn't work here?
Yes, sir.
Yes, because
Sir.
it reacts with the calcium ion or the magnesium ion, and it results in the formation of precipitate, which is curdy. It is just like the curdy substance or the precipitate.
Sir.
Got it? So okay,
Yes,
Yes,
sir.
sir.
let's that you will revise each and everything from this. Let's stop today's class here. Wish you all the way best. Have a nice day ahead.
Thank you, sir. Bye,
Yes,
sir.
sir. Thank you,
Most
sir.
welcome.
Bye,
Bye.
sir.
Meeting is being recorded.